We did start today's class with going over our piecewise homework answers. So if any of those from the notes or from the homework from Thursday are still causing you trouble, I will be after school 20 minutes today and an hour tomorrow. The type 2s, as I mentioned, will be back to you first thing tomorrow morning. Let's get started with absolute value. Who's heard of absolute value before? What does it mean? What's absolute value? Most people raise their hands, which is great. What is absolute value? Absolute value of just 2 is 2. What's the absolute value of negative 2? 2. So our knowledge of absolute value is when we're actually taking the absolute value of a number. And we all know that when we take the absolute value of a number, what happens to its sign? It's gone. And we'll talk about why that happens at another date. But you are absolutely correct with what you're saying. But what about an absolute value function? From our parent function chart, what do these look like? What are you all drawing right now? What shape? V's. Very good. Okay. So an absolute value function, by definition, is a piecewise function consisting of 2 rays. Meeting at a point called the vertex. As you've already correctly mentioned, they are V-shaped. When something has a characteristic that you could fold it in half and both sides will look the same, what's that called? There you go. These are also symmetrical. So we have our definition. Let's get our general. It says general. Let's try that again. General form. Let's use y. Y equals a. Y equals a, and then in our absolute value bars, we have x minus h, close the bars, plus k. There's kind of a neat connection to point-slope form. Point-slope form has to do with what kind of function? Linear functions, yes.
So if you see like the 2 up and down bars,
yes. So Cassie's question / observation, and she's right. If we see these absolute value bars, automatically we are working with an absolute value function. It's a dead giveaway. Okay. Back to our quick connection to point-slope form. What is point-slope form? Y minus Y1. Now, these are just this x1, y1 is a variable like any other variable, yes? And m, we just chose m to be m. Does m have to be m? Could we use another letter? Yes? Did we have to say X1 and Y1? Could we have used other letters? So what would happen if I did this? Oh my goodness. Check that out. Why not? Can I?
Yeah. I mean, it looks so weird.
It does, but is this kind of close?
Yeah, after here it looks on the other side. Yeah, then it's
Now these are definitely not bars. These are all parentheses on this side. Remember back in Algebra 1 how if you were given something in Poisson form, you could identify X1 and Y1 and tell me something about the point? Yes? And then what was M all about? The slope. So in the same way in Algebra 1 that you could pull information out of this function, we are going to be working on how can we pull out information from this function. So each term, each of these pieces, A, H, and K, affects the graph in a different way. And to help us discover those effects, we have a quick 10-minute investigation. You can work on this by yourself or with a partner. And in 10 minutes, we're going to come together and see what we've got going on. For right this moment, yes. So we're going to break for the question was, is this all we're doing for notes? For this moment, yes, we're going to break for the investigation, and then once we start making some conclusions, we will continue the notes. Malcolm? For you? Here we go. You're welcome. So we're going to pause from these notes for a second to work on our investigation. Notice the directions at the top. Examine the absolute value functions below and their corresponding graphs. So what that means is that graph A and the graph right beneath it, they go together. Make any observations about how the A, H, or K values may affect the graph of the absolute value function. So let's agree. For example, in graph A, what is A? What's H? We'll come back to that. I'm hearing a -4. And what's K? So at the top, let's all agree. Make sure we keep this in mind, general form. And the more we write it, the better we'll be. So Y equals what? What's my general form? A, bar. Okay, so if I see a -H here, and this is a -4, what is H for this piece? 4, not -4. Careful with that. All right, off with your discovery. I'll be around listening to your conversations. 10 minutes. Find some connections. There's space on the back, or you can write it on the side, or in your notebooks, wherever you choose to write it. So, your task is to figure out how these equations and these graphs are connected. So those values of A is 3, H is 4, and K is 1. All three of those numbers directly affect why that graph looks the way that it does. So the goal is, by yourself or with a partner, can you make connections between those three numbers we just talked about and that graph? A hint that I could possibly give you, notice where the vertex is, and do you see a connection between the vertex and points, the vertex and values in the function? Tiana, did you hear that hint? Save that for history. Focus. She found something. You can talk to each other. So if you hear somebody say they found something, ask them. Yes, observations on the back. Or on the side, wherever, just got to keep track of your thinking. However you choose to use the investigation, do so.
How are you a piecewise function? How is it? I thought I had. How is it a piecewise function? It's normally a piecewise function has multiple different equations.
Great question. So the question was, why is this a piecewise function? If I asked you if I gave you this graph and asked for the piecewise function, you would need two expressions to model this. You would need one equation for this ray with a certain restriction, and then a very different equation for this ray, right, with different restrictions. Yes? Here we go. So every absolute value function is made up of two rays, each with their own expression.
Wouldn't it just be the exact opposite?
For what?
If you're writing a piecewise function for this, because because they're symmetrical, it's just going in a different direction.
But can we guarantee that the intercepts would be exactly opposite?
Oh, no. Like, not here, because one goes like...
But there is a connection. When you say opposite, you're actually on the right track with one of the relationships between this ray and this ray. So if I asked you to count slope on this ray...
No, this one is -3, this one is 30.
Ooh, that matters. Jasmine knows something that matters. Start jotting some notes down. Keep discovering. Ladies, how's our discovery going? Taisha? Hi. How are we doing? Then keep looking at more graphs until you can figure out how to put it into words. Because if you have an observation, that observation for it to be true, has to be correct for every graph. So once you have an idea, check it against the other graphs. Yes. Does it? Check it out. Be careful. How do you count slope? Say it again. The connection between what you just listed and the graph. So right now they have a really good conclusion about A. If you heard what they were saying. Did you hear what they were saying? Juliana, can you share with them what you guys have figured out about A? K is connected to the vertex, but that's only half of a point. One more minute to start wrapping up some of your thoughts before we share out. So try to formalize your thinking. There's some awesome ideas here. Okay, let's see if we can formalize some of your thinking. Give me an idea. Who's got a thought? What can I write down in general? Say that again. Very good. So she said H and K. I'm writing it down exactly what she said. H and K are a point. So if I wanted to write those as a point, what would I write? Very good. That is true. H comma K is correct. What else did we discover? Malaysia? A is the direction of the rays. What do you mean by that?
Like it was +3, like for A. So if it's positive, the arrows go up, and if it's negative, then they go down.
Ah, okay. So let's say A is the direction of the function in general, not necessarily the rate. So, okay, I hear what you're saying. Let's use the word opens. So you're saying because it's a +3, it opens how? That is correct. So if A was a -3, how would it open?
Yeah.
Very good. That is true. What else can we say? Very good. A is the slope. There were some other good observations about that. Does anybody want to share what they noticed? So your job, catch up on if we fill out anything else, and then you're going to run this through for each of the graphs.
Good morning, East Oakland High School. Today is October 11th. Please stand for the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. We understand it's cold outside, but hoodies are not part of uniform. There are plenty of school fleeces in room 173. Students are reminded to be responsible by being on time and in uniform, to be respectful by treating others with kindness, and to be safe with words and actions. Have a day of excellence.
So I'm actually writing down something that the ladies in the back observed. Positive of that A gets me one ray, and negative of that same A gets me the other ray. That's what we get, how we get both directions. That was a fantastic observation in the back. Any other observations? Connect this. The only other connection I'm looking for before the end of class is this is what point? There we go. Very good. So your task for tonight is on the discovery to go through each of the graphs, identify the vertex, identify A, if it opens up or down, and then what is the slope? What is A? Great job. Yes. Because how many graphs are on the front? 9? So you have 9 opportunities to identify H comma K, either from the graph or from the equation. They should back each other up. What's A? Does that mean it opens up or down? And then prove to yourself that you can count both ways. And then we will formalize some of our discussion and continue our notes from today's class. All right? Nice job today.
So wait, how does positive and negative A direction one direction?
Start from the vertex and count slope in one direction, and then count slope in the other, and see how they're connected. Yes, you can do it on a separate piece of paper. Great job, folks.